Welcome everyone. Today we're going to solve a classical mechanics problem. Specifically, it's going to be about uniform circular motion. Let's first remind ourselves of what uniform circular motion means. So if we have a circle and there is a runner. I know I'm not a painter, I'm not a good artist. Basically, that's our runner. He runs at a constant speed. Speed is, 10 meters per second. Note that it doesn't mean that the velocity is constant. Velocity is not constant because the runner is changing its direction. The direction of the velocity changes. And although the magnitude of velocity stays the same, the direction doesn't stay the same, which means there must be acceleration. In order for velocity to change, we need to have acceleration. And if acceleration is acting on the object, it means that there should be some external force. And I can give you another clear example of what that external force is going to be. Imagine we have, oh gosh, what's going on? Imagine we have V1 right here. And just about after a few seconds, here we have V2. We know that delta V is equal to the final velocity minus the initial velocity. And to subtract vectors, we simply need to connect them tip to tail and find the magnitude of this line. So we're gonna add it right here. It's vertical. Maybe it seems like it's a little tilted, but I did my best to draw it vertically. And this is going to be our delta V in this direction. And believe it or not, we can find the acceleration based on this delta V. We know that the acceleration is equal to delta V over delta T. So if delta V is pointing in this direction, it means acceleration should also be pointing in this direction. And this is where I'm going to introduce you to the concept of centripetal acceleration. It is equal to the velocity at a certain point squared over the radius of the circle. That was a quick review, and now let's tackle the question itself. I'm going to erase all of it. You could take a screenshot if you want to look back at it or to save it for some reason in case you need it at any time in the future. So an athlete who weighs 800 newtons, that's a pretty weird unit to use for weights. Usually we use kilograms, is running around a curve at a speed of 5 meters per second. Let's draw an athlete again. We have an athlete equal to 800 newtons. He's running around a curve at a speed of 5 meters per second. Let's draw a curve. Then his speed, which is the absolute value of velocity, is equal to 5 meters per second in an arc whose radius curvature is 5 meters. So the radius is 5 meters. Assuming his weight is equal to the force of static friction, so his weight is 800 newtons as they told us right over here, his weight, 800 newtons, is equal to the force of static friction. Find the centripetal force acting on him. Do you remember centripetal acceleration? I told you that centripetal acceleration is equal to velocity squared over the radius. Well, technically, the centripetal force is equal to mass times centripetal acceleration. This comes straight out of Newton's second law, which is net force equals ma. But one thing to note about the centripetal force is that you don't need to draw it on your free body diagrams, because the centripetal force is the result of one or two more forces that you already drew. So now we can figure out the centripetal force by just plugging in the values. First, let's figure out the centripetal acceleration. We have the velocity right over there, and since this is squared, the units are going to be positive. The sign will be positive. Even if the velocity here is negative, it's still going to be positive because it's squared. So it's going to be 25 over the radius is 5. So centripetal acceleration is 5 meters per second. To figure out the centripetal force, we need mass as well, and the mass is 80 newtons. Well, look, the weight is basically mass times the force of gravity. Weight is 800, mass, the force of gravity is 10. So mass is equal to 80 kilograms. 80 kilograms. This means that the centripetal force is equal to 80 kilograms times 5 meters per second, which gives us 400 newtons. So the answer is centripetal force is 400 newtons. What could happen to him if r were smaller? Well, let me rewrite this. Centripetal acceleration is equal to mass times the velocity squared over the radius. If r were smaller, if this curve were to be only 2 meters, then here the value would be too big. The value would be too big, and potentially it could reach 800 newtons. If it reaches 800 newtons, it's going to be equal to his weight. So if the static friction is equal to his weight, the athlete is going to slip. Right now, he's running because his weight is 800 newtons and the centripetal force on him is 400 newtons. So the difference is 400 newtons. But if the centripetal force gets too high, when r gets too small, centripetal force gets too high, and if it gets too high, the athlete is going to slip. He's going to fall on the ground. Thank you for your time.